Okay, welcome back to Greenplum Summit 2020, our very own reimagined digital customer conference. My name is Jacques Eistock, and for our next guest, I'd like to bring Nikhil Kak to the stage. Nikhil is a software engineer working on our efforts around Greenplum running on Kubernetes. He's going to take us through some of what we've learned today from our other speakers and show us just how easy it is to put it all together for real. So, Nikhil?
Hello, everyone. My name is Nikhil Kak. I'm a software engineer, and I work for the Greenplum Kubernetes team. And today, we're going to talk about analytical components in GP4K. To be more precise, we're going to talk about MADlib with GPUs, Pxf, and Gptx in GP4K. Next slide. Here is the agenda. So why even use GP4K for analytical workloads? We'll talk a bit about that. Then we'll talk about how to configure your components like Pxf and Gptx. Then we'll talk about how to configure your Google Kubernetes engine for your GPU use. We'll also talk about how to configure MADlib. Then we'll do a video demo of a deep learning query which shows you how to run GPUs on GKE on GP4K. I hope that excites you. And then we'll dive into some future work. Next slide, please. So why use GP4K for your analytical workload? So the easy answer to that is because you can so easily set up your Greenplum workbench for your data science experiments, like the ability to use GPUs or use Gptx, and you can get started in just a few steps. As you will see in a future slide, it's as easy as creating a YAML file and applying it, and that's it. You can also save resources and spend by only using components when you need it. So what you can do is there's a plug and play architecture. You can use a component, then remove it, then use it again. So you save a lot of resources and spend. The analytical components that we are going to talk about today are the platform extension framework, which is using which you can connect your Greenplum database to your external data source. And as we know, the data lives everywhere in S3, GCS, Hadoop, whatnot. So using that, what you can do is you can bring your data into Greenplum so that you can run a pipeline and run analytics on it. The next one is Gptx. As you already heard Reda talk in another session, Gptx is used for querying, analyzing mass amounts of unstructured data like emails, Twitter feed, any unstructured data inside of Greenplum. The next one is Apache MADlib, which is the in-database machine learning library, which is used for machine learning, obviously. And then today we're going to talk about how to use deep learning query using GPUs. So I hope this gets you excited. Next slide, please. All right, so how to configure Pxf and Gptx. It's as easy as creating a manifest file, applying that manifest file, and running your query itself, as we'll see in a future slide. Next slide, please. So when you create your Pxf manifest file, there are two sections to it. One is the Greenplum cluster itself, and it's a YAML file. The Greenplum test cluster tells you you have a master and standby, and how do you want to configure your master and standby? And you say, oh, I want this much memory, this much CPU, this much storage. For your segments, you say how many segments you want. Here, the primary segment count is 1, so we'll only get 1 segment, but you could horizontally scale it to have as many as you want. You can also specify your CPU, your memory, your storage, and other things. The next section is the Greenplum Pxf service, and you start by saying how many replicas you need, which is essentially saying how many Pxf servers do you need. So all these replicas get converted as pods. So here we will have 2 pods, but obviously you can horizontally scale it, and you can have as many pods as you want. And then you can specify how much CPU you want, how much memory you want based on your workload. The next thing you do is there is a Pxf configuration, where you create a secret, which here we have called it my Greenplum Pxf configs, and I'll show you in a future slide how to create that secret. And then some configuration params as if it is S3 endpoint or GCS endpoint, what is your bucket name, and if optionally if there is a folder in your bucket, what is the folder name, and also wherever your data is coming from, essentially. Next slide, please. Similarly for Gptx, the first section is the same, the Greenplum cluster, it's configured the same way. The Greenplum text itself has 2 subsections in it, which is one is the Solr and one is Zookeeper. And Reda has already talked about these 2. We need Solr and Zookeeper to create and manage indexes in the Gptx cluster. So for Solr here in the example, we have said we need 2 replicas. And for Zookeeper, we have said we need 3 replicas, which is the minimum we need for a Gptx cluster. And as you see, CPU, memory, storage, all of these things can be configured according to your workload. So I want to emphasize how easy it was to go from nothing to having this YAML file, and you'll see in the next slide how easy it is to apply it. So before we go to the applying part, what you also have to do if you want to use Pxf is you create a secret file, a secret called my Greenplum Pxf configs, which was referred to in a previous slide as well. And all you have to do here is you have to give your access key IDs and secret access key. And this allows Pxf to authenticate, and then you can retrieve content from S3 or GCS or wherever you want to. And this is, I want to emphasize, this is a one-time step. And once you've authenticated it, all you have to do is change your, maybe change your buckets, maybe change your folders and whatnot, and that's it. So this is a one-time step and you're done. Next slide, please. The next step is applying the manifest file, which is as simple as kubectl apply and then the manifest file itself. In this example, I have combined Pxf and Gptx. In the slide, I showed you them as separate, but here I've combined it. So you see one manifest file which has a Greenplum cluster section, a Pxf section, and a Gptx section all in one. One thing to note is that this assumes that the Greenplum operator is already installed, but I'm not going to go into detail on how to install it. You can look up the GP4K docs for more details. So once you apply this YAML, it says all your services are created, your Greenplum cluster, your Pxf, and your Greenplum Tech service. And let's see how the output looks like. Next slide, please. Once you apply the manifest, you can run kubectl get all to look at the state of your cluster. And as you can see, based on our YAML, we have one master pod, one segment pod, as we had said in the YAML file. We have two Solar pods, three Zookeeper pods, two Pxf pods, and we have a bunch of services, Solar service, Zookeeper service, Pxf, and Greenplum. And again, it only took about a few seconds for it to provision all of this. And given that it is a small cluster with a few resources, but it's pretty neat and pretty interesting to see how you had nothing and now you have a cluster where you have all of these components working together, running together, and now we can see how you can run your workload on this cluster. Next slide, please. So once you have the cluster, all you have to do is run your query. So here I have an example query for Pxf. So you log into the master pod. So you see at the top that you are on master 0 because that's where everything starts from. You select from PG extension just to make sure that Pxf is installed. And we see that Pxf is an extension that is available. So we say, oh, let's create an external table. So we create an external table. We specify the schema and we give it a location. And the location is the location of your data source. So it says, based on the secret that I created, go to Pxf test data and find my data there. And obviously the schema has to match. And there are other parameters in Pxf, and you can look up the Pxf docs for more details. And once you've done that, now you're ready to use this external table in your query. So you can do select count star on it. You can convert it to a heap table. You can run any other analytics on it. And that's about it. Next slide, please. Similarly, with Gptx, all you have to do is you create a demo table. Initially, the index status is nothing because we haven't created an index. And then we create an index and we can query the index and see that the index was created. And so all of this is using Solar and Zookeeper in the background. And again, I want to emphasize how easy it was to get to running Pxf and running Gptx, which can be a bit tricky to set up sometimes. Next slide, please. Next, we're going to talk about MADlib, which is a slightly different component when it comes to configuration than Pxf and Gptx. So we'll see how to configure a Google Kubernetes cluster with GPUs. We will see, we'll apply a manifest to install Greenplum, and then we'll run a deep learning query. Next slide, please. So our experiment was done on Google Kubernetes engine. So it's easy to create a cluster with GPUs there. So all you do is you go to the console and you say create a cluster. And here I show you a couple of interesting parameters there. We chose US Central 1C as our zone because that's where the Tesla P100 GPUs are present, and that's what we wanted to use today. We chose the greatest and latest Kubernetes version that was available to us. Next slide, please. The next is setting up the node itself. While setting up the node, we said we want an Ubuntu image. We said we want an N1 series family because of the type of GPUs that we wanted. And then at the bottom, you will see we are using Tesla P100 GPUs, and the number of GPUs is 1. What that means is we will have one Tesla P100 GPU per node. And in this example, you don't see it here, but we have 3 nodes. So we'll have one GPU per node and 3 GPUs overall in the cluster. Next slide, please. One other thing that you have to do is you have to apply your device drivers. And the way you do that is you say kubectl apply daemon set preloaded.yaml, which is a file that's provided by Google. And as soon as you apply it, your drivers are installed. And as you can see in the output, the second last and the third last items show you that the device plugins and driver installers were installed. So this installs NVIDIA drivers on the nodes, which is a step you have to take. Next slide, please. The next step is applying a manifest file. All you have to do now is install Greenplum. So here I have not shown Gptx and Pxf, but that doesn't mean you can't use it. I just wanted to keep it simple, but you could easily have had a Greenplum cluster service, a Pxf, and a Gptx. You don't see a MADlib here because MADlib is not a service in GP4K. MADlib is installed inside the image itself. So when you start Greenplum, you will have MADlib installed already on it. So you don't need it as another service that gets installed. So you don't need anything to do to your YAML file. So as you see, there is more storage and more memory here because in our GPU example, we wanted to give more memory and more storage. And then once you have this YAML file, as you have seen before, you just apply this YAML and your Greenplum cluster will be created. All right. So here on this tab, what I'm showing you is the output of GP segment configuration, which tells you the status of the cluster. And it says that you have one master segment pod called master 0, 2 segment pods, segment A0 and segment A1. And this is how our cluster is defined right now. And as we go to the next tab, a point to note here is the left 2 tabs are the master tabs and the right 2 tabs are the segment tabs. So segment A0 and segment A1. The other interesting thing to note here is the outputs that you see on these 3 tabs is the output of a utility called NVIDIA SMI. And what this utility does is it tells you how many GPUs are installed on your system and how much memory they are using. So right now it's saying that all these 3 master and the 2 segments have one GPU on it and nothing is running on it and they are using 0 MB. Our goal today is to run a deep learning query and to showcase that only the segment pods will use GPUs and not the master pod because the data does not reside on the master pod. And as you have heard Ekta talk about Keras and TensorFlow running only on segments, only the segments should use the GPU. So what we'll do now is we will start creating our database and we'll call it test deep learning. And once you've created the database, you can install MADlib by running madpack and you install it and you see MADlib 170 installed. The next step is we create some dummy data. For this example, we'll create a small data set, which is just your classic iris data set. And then once you've created it, there's some pre-processing that you have to do, which I'll skip through because it's not really very relevant to this demo. Once you have pre-processed the data, you have to create a model that will eventually be passed to TensorFlow and Keras. So that's in the SQL file. And all this is, it's a bunch of model parameters and arguments that get passed to Keras and TensorFlow through MADlib. Then the more important query is this run deep learning query.sql, which calls this function called fit multiple model. And Ekta has already explained what this function does. It's essentially calling Keras and TensorFlow. And we use set GPUs to true. And this means that, and number of iterations to 5. And this means that whenever we run our deep learning query, it will use GPUs. Now we will see that once we run this query, note that the right 2 tabs will start using GPUs. Wherever you see 0 MB, it will start showing around 15 GB. And the left bottom tab will not use any GPU at all. So in just a few moments, you will see, there you go. It's at around 15 GB now. The bottom one is also at 15 GB. So both the segments are using 15 GB GPU, and the master is not using anything because it should not be. And we will see so we have 5 iterations. As we go through all of these iterations, once we are done with it, we will see that the GPU utilization goes down to 0 because the query has finished. And then the other thing to note here is that this code that you're seeing right now is not available for GA yet. So GB4K on GPUs is not released yet. We will hopefully be able to release it in the future sometime. All right, so once this query finishes, you will see that there will be an output. I think there's just a few seconds, and there you go. There is some learning output, shows you accuracy results, how your loss was. And note that this was a very small example. In real world, you will have a much bigger query, which will use GPUs for longer and which will be much more efficient. This was just for demo purposes. All right, I hope you enjoyed the demo. And I hope this convinces you that using GP4K with these components is a very compelling case. All right, let's talk about some future work. There are a few other components that we are going to support in the future with GP4K. The first one is GP Command Center, which has a very sleek UI. You can do a lot of administration stuff from there. Then there is a GP Backup component, which is the backup and restore utility. There's GPSS, which is streaming data in and out of Greenplum. Then there is PL4K for Python and Java, which is PL containers for Kubernetes. Note that R is already supported in the latest release version of GP4K. So if you want to use PL4K with R, you can use it today. Thank you.
Thank you so much for taking us through that, Nikhil. The whole Greenplum with Kubernetes sure does sound interesting. Obviously, there's a lot of momentum behind Kubernetes. And the fact, just to clarify, that Greenplum already is released on Kubernetes and available. And of course, we continue to iterate on it, which is part of our infrastructure native narrative where you can run Greenplum wherever you want. So thanks again, Nikhil.